Hello, I'm Chris Athanas. I'm a sit over here a little bit. I'm a KMP developer. The AI is getting trained up. That's going to program the tool that's going to come out with the tech support team to close that custom. They tell me it's a custom portal. There's only like a few made of it, and the company went out of business. It's been restarted. You don't know all the whole story. So they should be out on Tuesday. They said to close that thing up. We'll see. Okay, so what we're looking at is the difference between derived state of and remember. And it's like, okay, what is all this stuff? This is basically just an optimization for lazy lists. So here's the problem, and I'll get into the code in a second. So as you scroll up in these lazy lists, you get these massive numbers of you see it kind of gets bright down here as you scroll up and down. This is what we're talking about. This optimization for dealing with this. So I've got a couple use cases over here, and we're showing off the first one, and it's basically a standard app, compose app. It's just here's the composer with the scaffolding. Here's a lazy column. Here's a sticky header, so this little thing stays on the top. Here's this button to enable and disable that little scroll to top button down here, and then we just fill up with 100 items, and those are the items. So that's all that is. It's nothing crazy. We'll get into this what this enabled thing does in a minute. And then we hope down here to this example one, which is going to be okay, here's the code we're going to be looking at here. This scroll to top button, which is this thing right. Where do we put this? I put this right there. So that's where that is. So it's turning this floating action button on and off. That's the example use case. This is, and then I'll get into like, well, this seems like the only use case is for this lazy list stuff. There may be some other use case. If you know that, let me know in the comments below. And here's the three things. So here's the first one, and this is how it's set up right now. It's just using a remember, and it's trying to see what the first item is. So as you scroll, there you want to have this thing to pop up and invisible while you're at the top. So that's the basic idea, and we'll get into that as enabled. Basically, just it turns it on and off, and every time it does recompose. You can see it there. Okay, so and then so that's the current way, which has lots of recomposes. As you scroll up and down, it can be kind of inefficient, I guess, and if you had a more complex calculation going on, I could see this being a problem. So it's basically doing what they call a debounce. Now let's look at my next example I have set up here. So, and let me compile this while I pause where it is. Okay, so it's running now. And let's open this up and scroll. Oh, not that one. This is scrolling. Here we go here, and you have to open this up again. It's kind of lame how it does that, but it only does it only changes now when this thing changes. When this value changes, that's when it actually does the debounce, and it won't actually do the change until the user has stopped scrolling. So that's the idea. So it basically does a debounce, and that's the final value at the end. But what if you wanted to this is enable thing? So right now, it doesn't respond to that. You can turn this on and off, and it doesn't see this right now because this is not being calculated by this derived state. So it's not being used in the calculation. It's only seeing the initial value, and then it captures it, and the only thing it's looking at is this changing value. This is just how it's set up. I think it's only monitoring the first one. Is that the idea? I guess I'm not sure what that's all about. But the way you fix it, and this is the known fix, is we'll comment that out, and then we'll go down here to this better block here, and uncomment this, and I'll compile that. All right, so that's compiled. And so the difference is here, as we scroll to the top, we can turn this on and off, and it'll actually respond properly and still have the minimum number of recomposes. That's so annoying how it does that, but that's the basic idea behind this whole thing. I wish it would leave that open, but that's what we're dealing with right now. So that's the big idea with the lazy list stuff. And I did another example here. This is example 2, which is going to show like, here's the example 2. So let me get this bigger open here. So what this one is going to show is the two ways of looking at it. So we got the remember here and the derived. And I'm just going to be two. Oh, hold on a second. Let me show you. Yeah, so I couldn't find a difference there. This increments the value here, and it doesn't do any updates here. So it's this. I don't know what the use case is in this case because it's just completely skipping over it because it's at the end it sees the result. So it's just changing. It's just checking to see if it's odd or even. And I do the yield here, so it's allowing it to catch up. So it's going to do a debounce. So let me pause here. All right, and so here I got it. Now I'm using a little delay, and let's look at the counts here and reset these. And you can see it doesn't really. This one has okay. So one with a longer delay, as if there's a little more processing time, it then allows it to update more. So there's doing some kind of debounce here inside this stuff already, and it doesn't. It behaves exactly the same for remember, just the remember style and the derived style. So I don't know. So if they found another use case other than this for lazy lists, let me know in the comments below. But that's basically it. That's the big deal. And give me a like and subscribe. And I'll talk to you soon. And I'm Chris. Bye.